force on the curved surface. So for this we consider a curved surface of area A which is completely immersed in a liquid of specific weight omega. Here let us take a sketch of that. So here is a curved surface of area A. So consider a curved surface. This is the curved surface of say area A, and now you consider an elementary area out of this curved surface, so which is shown here, and the force acting on this elementary area is a dF. So you know that the pressure force will be normal to the surface. So here for this surface you take a tangent which is acting at an angle theta. So I have shown the force F, that is dF, will be acting normal to this tangent. So tangent is making angle theta by pair of perpendicular, so this angle has to be theta with respect to vertical. So the dF is making an angle theta with respect to vertical. So what happens in the curved surface is that in the vertical surface, when we were calculating the total pressure force, we used to consider an elementary area which is at a depth x. So now you can calculate the pressure intensity on that and hence find out the pressure force, which is pressure intensity into area. Like this, when you consider the different element, the entire area to be made up of elemental areas, and find out each of the pressure forces on the elemental areas and add up all the pressure forces, you will get the total pressure force. But in this case, so when the depth increases, the direction of the force dF goes on changing. So now when you come over this point, again the direction is different with respect to this direction. So by taking the pressure force on each of the areas, you cannot go on adding that because they are not parallel to each other. So that's the reason here in the case of a curved surface, this pressure force is resolved into two components. So one is the horizontal component, another is the vertical components. So separately we'll find out the horizontal pressure force as well as the vertical pressure force. So for this, so that's why this force dF is resolved into two components. So one is dFH, another is dFV. So from this figure you know that here, so dFH is nothing but if you resolve it, so it will be, so here it is dF sin theta, whereas dFV is nothing but dF cos theta. So now we'll find out the total pressure force in horizontal directions as well as the total pressure force in the vertical directions. The same figure is shown here. So now we see here we have taken the elementary area, so therefore the pressure that is at depth x here. So therefore the pressure intensity on the elementary area is nothing but, you know that it is nothing, it is always depends on the vertical distance, so it is omega into x. So now you can find out what is the pressure force on the elementary area, which is given by P into dA, which is P is omega into x, so omega x into dA. Now, so you know that let the tangent to the elementary area make an angle theta with respect to horizontal. So if you resolve this, I told you why to resolve. So if we resolve dF into two components, so one is the horizontal component, that is horizontal component, another is the vertical components. So from this you can know that, so the dFH, which is the horizontal component, is nothing but dF sin theta, whereas the vertical component dFV is dF cos theta. Now shall we consider the horizontal component FH? So now you know that dFH is nothing but dF sin theta, but dF is omega x into dA. So sin theta remains as it is. So therefore dFH, that is the horizontal force, is nothing but omega x dA sin theta. Now we can consider the entire curved surface to be made up of such elementary areas and find out the horizontal force on each of the elementary areas and add and sum it up. So you will get the total horizontal force. So therefore the total pressure force is nothing but integral of omega x dA cos ds sin theta. So but omega is a constant, so therefore it is integral of dA sin theta into x. So what is this dA sin theta? dA is nothing but the area. dA sin theta is nothing but the projection of okay, so this is nothing but the projection of dA onto a vertical plane. So therefore dA sin theta is nothing but the projection of the elementary area on a vertical plane. So therefore, so what is dA sin theta into x? So it is nothing but it is the moment of vertically projected area about the free surface. So distance is taken about the free surface, so therefore it becomes the moment of the area. So integral of this is nothing but the first moment of area. So it will be integral of first moment of area is nothing but it is the area which is projected onto the vertical plane multiplied by the CG distance which is got from your engineering mechanics, as we did in the vertical surface and the inclined surfaces. So therefore, so ds sin theta is what? It is the projection of elementary area on the vertical plane. So integral of ds sin theta into x is nothing but it is summation of first moment of vertically projected area about the free surface. So this is what I have done it. So here I have taken, so each of the areas are projected so that we'll get the vertical. This is but so this projection, this entire curved surface is projected onto the vertical. So this curved surface has got some length perpendicular to the screen. So therefore when I project it, we'll get this depth into the length perpendicular to the screen. So that means it will be a rectangular surface, something like this. So therefore this will be the, because at this point you project onto the, and this point, this plane is already there, so you will get this line that into this length. So this length of the curved surface is this, so you will get this will be the length of the curved surface. Okay, so that means this depth into length will give the projected area. So according to engineering mechanics, it is nothing but, so this all is multiplied by x, so therefore each of the areas are multiplied by, so you will get first moment of vertically projected area. So that is nothing but the total, it is this area into the CG distance. Okay, so that is got by the definition of CG. So therefore this is nothing but area on a vertically projected plane into the distance x bar. It is not, the x bar is not the CG of the here. It is not the CG of this diagram. It is CG of the, this is CG of this, not CG of this. Okay, so you have to be very careful. So here you have to take the CG of this vertically projected area and multiply by the distance. So therefore now, so here FH is nothing but, that is the total pressure force, nothing but omega into APB, that is area on the vertical plane into the CG and into its CG distance. So like this you try to find out. Again now we'll go ahead. So what is x bar? It is distance of CG of this projected area from the free surface. So next is to find the vertical component FV. We know that DFV is DF cos theta, but DF is the thing but omega is into dA. So into cos theta will give you DFV. So now we have to require to find the total pressure force, so which is Fe. So if you take DFV for all the elemental areas and then sum it up, so that if you take integral or summation, you will get the vertical force. So Fe will be now omega, if that is the integral of omega x dA cos theta. Since omega is a constant, so it is taken out of the integral sign. So dA cos theta into x. So integral of dA cos theta into x. So here you know that what is dA cos theta. So dA is the area, so into multiply by cos theta will give you the projection of elemental area on the horizontal plane. So that area multiplied by so this is nothing but the projection of elementary area on the horizontal plane. If you multiply by x, you will get the volume. So that means here if I take see here, so this is dA. So if I project onto the horizontal plane, I'll get dA cos theta. So dA cos theta into x will give you volume. So it is nothing but the volume of water or fluid that is contained from the curved surface to the free surface. So if I take some summation of all these things, it will give me the entire volume. Okay, volume of fluid right from curved surface to the free surface. So therefore, so now you can take the integral dA cos theta dx will give me volume of liquid from the curved surface to the free surface. So if I take this volume and multiply by specific weight, I'll get the weight of the liquid. So therefore, what is vertical component? So vertical component is the weight of the liquid from the curved surface to the free surface. So therefore, so if you just find out what is the weight of the liquid that is contained from the curved surface to the free surface, you will get F. So therefore, you can now FH, Fe. So take the resultant force, which is root of F square plus Fe square, and also you can take the inclination of resultant force, which is given by alpha or anything. Alpha is tan inverse of Fe by Fh. So this is how you find out the vertical pressure force and horizontal pressure forces on the curved surface. So now you know the basic concepts which is related to the curved surface. So using this concept, we'll try to solve few problems on the curved surfaces, which will be very important. So it can be a curved surface which may be in the form of a quadrant, or it may be form of a circular surface, or it may be like a semicircular, or very important like sector gates of 60 degrees or 90 degrees. Generally sector gates are those which are mounted on spillways where the water is stored on the upstream side, and when the water is stored, so you can find out what will be the force that is acting on the sector gate. So we'll go to the problem here where we are required to find the magnitude and direction of the resultant force on a gate of length 3 meters as shown in the figure. So this is the figure where you have, so now this is the sector gate which is AB. Okay, the like not a sector gate, so some quadrant. Okay, it is a curved surface or okay of length 3 meters, which is perpendicular. The length 3 meters is perpendicular to the screen. Similarly, you have so this AB uh, is a curved surface which is of radius 2 meters. So that means OA is 2 meters as well as OB is 2 meters. Now we have this is the water surface. Okay, nothing is mentioned about the liquid. It should be assumed as water. So specific weight is 9.81 kilonewton per meter cube. So now you know that the top of the gate is 3 meters from the water surface. So that's the data given. So now that's what I have said. The radius of the gate is 2 meters. Similarly, length AE or the height AE is the 3 meters, which is above the gate. So you know that length of the gate is given as 3 meters, which so now when in order to find the horizontal force, we have to project this AB onto the vertical plane. The projection of AB on the vertical plane is AO into length. So that is what is that. So AO is nothing like 2 meters. Okay, so 2 meters, this is 2 meters into 3 meters. Okay, so that will be the projected area, which is known as APB. Here we are required to find the projected area, which will be 3 into 2. It's not the area of the curved surface, it is the projected area, which is 3 into 2. So now project AB onto the vertical plane, which is AO, that is 2 meters into length of the gate is 3 meters, so you will get 6 meters square. So the distance of the CG of the projected area has to be taken. So you know that for rectangular the CG will be exactly at the middle here. So here this is 3 meters, so 3 plus 1 is 4 meters, so x bar will be 4 meters. Now I am able to find out the horizontal pressure force, which is specific weight into area into x bar. So here 9.81 into 6 is the projected area on the vertical plane, into 4 meters is x bar, so that will give 235.44 kilonewtons. So how to find the FV? So here it is nothing but the weight of the liquid from the curved surface to the free surface. And now in order to find the weight, it is specific weight into volume. So but volume is nothing but area into length. So now I am able to find, because it is acting directly on the surface. So this is the area that you are to require to find out, and then after finding out the area, if you multiply by the length, you will get the volume. So that is nothing but it is area ACB plus area ACDA. So these are the areas that you have to take in order to calculate the weight. So therefore, so area ACDE is nothing but 2 meters into 3 meters, which will give you 6 meter square. And similarly, the area ACB is nothing but the rectangular area OACB minus the quadrant area. So therefore, it has to be like area ACBO is 2 meters by 2 meters. So this is 2 meters by 2 meters. And the quadrant area is nothing but here it is pi r square is the area of circle, pi r square by 4. So shall I write it here? So it will be pi r square is the circle, so pi r square by 4 is for the quadrant. So if I do this, so I'll get point, okay, so which is 0.86 meter square. So now you know both the areas, so therefore I am able to find out the weight of the liquid. So what is weight? It is specific weight into volume. So volume is nothing but area into length. So area I have taken as 6 meters square plus 0.86 will give the total area. If you multiply by 3 meters, I'll get the volume. So that will give you FV. So it is 201.89 kilonewtons. So knowing FH and FV, we can find out the resultant force, which is root of FH square plus FV square, which will give you 310.15 kilonewtons. Similarly, if you want to find the direction of resultant force, it is tan inverse of FV by FH, which gives 40.6 degrees with respect to horizontal. So that is how you find out the total resultant force on the curved surface AP. So next problem is to find the magnitude and direction of resultant force on 60-degree sector gate of radius 6 meters and length 4 meters as shown. So this is the sector gate which is given so here, and again the water surface is here. Okay, so here this is the curved surface, which is AB, and length is 4 meters, which is perpendicular. So therefore whenever I take this length, so this in the projected area it comes 4 meters, and this sector gate has to be projected onto the vertical plane, which is BD, so that you know how to find out this. Okay, knowing this radius and 6 meters radius, you can find out this BD, and that comes to about 5.195. okay, so now this is how this is the data that is given. So now I am able to find out what is the vertical projection, that is okay, the vertical projection of AB is either AC or BD, so which is if this is a 60 degrees gate, so I will make, so this is 60 degrees. Okay, so now how to find out? I will go for sine 60. So sine 60 is nothing but BD by 6. So therefore BD is nothing but 6 sine 60, which comes to 5.195 meters. So that's how the vertical projected area can be calculated, which is 5.195 into 4, which is APV. So this is APV. So okay. So now shall we go for Just if you want to find out OD, so we can go for cos 60 later on. So cos 60, so cos 60 is base by hypotenuse, so I can calculate OD, which will be 3 meters. So this will be 3 meters. So this will be 3 meters. So 6 cos 60 is 3 meters. So that will enable me to calculate AD. So why I need all these things to calculate this area? So I can take this entire area ABCD or ACBD minus okay, so minus okay, or I can calculate area of a sector minus area of a triangle. So like this, something like that. Okay, or okay, area ACBD plus area of a triangle minus the area of a sector will give area ACB. So that's why it is needed. So I'll tell you later on. So 6 into cos 60, which will give you 3 meters. Okay, so next I want to find out the length AD, which will give me OA minus OD. So OA is, you know that it is a radius, which is 6 minus 3, so it will give me 3 meters. So what is the projected area of the curved surface on the vertical plane? It is 5.195 into 4, which gives 20.78 meters square. So therefore, what is the distance of CG? It is nothing but rectangular surface, because here you have directly it will be at the center. So therefore 5.195 divided by 2, which is 2.598. So that gives horizontal pressure force, which is omega APV into x bar. So which is 9.81 into 20.78 into 2.598. So which is 529.61 kilonewtons. So next is to find out, so now here the area of this triangle OBD. So I told you in the previous slide that OD is 3 meters, okay, and this distance is 5.195. So therefore the area will be 7.79 meters square. Area ACBD is nothing but area AD into BD. So you know that AD is 3 meters, okay, 3 meters, and BD is 5.195, which gives 15.59 meters square. So therefore, in order to find the area ACB, I'll find out first area of sector OAB. So area sector OAB is nothing but half r square theta. So half r square is 0.5 into r square is 6, 6 square 6, theta is 60 degrees. I'll convert into radians by multiplying by 3.14 pi by 180. So that gives the area of the sector. So now I am able to find out, because what is Fe? It is the weight of the liquid from the curved surface to the free surface. So that means it is area ACB. In order to find area ACB, so that is the weight of the liquid from the curved surface to the free surface. So that is 9.81. So total area, that is 7.79, is the area of the triangle. Then you add area of a rectangle, which is ACBD. Then you deduct the area of the sector. So that's what I have done, so to get the area ACB. Otherwise we cannot calculate area ACB directly. Then multiply by length to convert it to volume, and multiply with Suzuki to get the weight. So that was 178.15 kilonewtons will be Fe. So therefore the resultant force will be root of Fh square plus Fe square, so which gives 558.77 kilonewtons. So direction of resultant force can also be determined, so by taking tan inverse of Fe by Fh, which is 18.6 degrees with respect to horizontal. So I gave an example of a quadrant, also I gave an example of a sector gate. So which is, here you find that the water is directly acting on the curved surface, so therefore it is very easy problems. So I will give you the next problem, where we are trying to find out the magnitude and direct resultant force on a cylindrical gate of diameter 3 meters and length 4 meters as shown in the figure. On left side there is water for a height of 3 meters and oil of specific gravity of 0.8 on the right side of the gate for a height of 1.5 meters. So you are required to draw the figure. So this is a cylindrical gate of diameter 3 meters. So that means AB is 3 meters or CD is 3 meters, and the length perpendicular is to the screen is 4 meters. That is length of the cylindrical gate is 4 meters. So on one side there is water, that is left side, for height 3 meters, and another side it is for height 1.5 meters is oil of social gravity 0.8. So this is how you draw the figure. Now I should be able to find out the resultant force on the cylindrical gate. So this is the data that you have. Uh, so now first we'll find out what is FH and FV due to water. Okay, so now you know that the projected area. So what is the okay? So which is the curved surface? The curved surface. So now due to water, the curved surface is now ACB. Okay, curved surface is ACB. So this ACB has to be projected onto the vertical plane. So that will be AB now. So once you project entire thing onto the plane, so it will be AB into length. Length is 4 meters. So it will be AB is nothing but 3 meters, that is the diameter, into 4 will give you projected area. So that will be nothing but 3 into 4. Okay, so that is 12 meters square. So now distance of that. So distance of so here this is the projected area. So if you want, I will draw this. So this is 3 meters. This is the projected area. So like this. Like this. Okay, so mark the CG. So this distance you took. This is the X bar distance. So this X bar distance is nothing but half of 3 meters, which is 1.5. Okay, so that is 1.5. So now I am able to find out horizontal pressure force due to water, which is 9.81 into 12 into 1.5, which gives 176.58 kilonewtons. Now I am required to find out the vertical force, that is Fv. So in order to find the vertical force, so this is what we are trying to find out. I'm just trying to find out for what is for ACB. Okay, so what is I already determined the horizontal force. I want to find out the vertical force here. So how to find out? So I told you that it is nothing but the weight of the liquid from the curved surface to the free surface. So in this case, okay, so consider this CB. So this is the CB. So now it is nothing but, so if I consider CB, this is C and this is B. So it is weight of the liquid from the curved surface to the free surface. Okay, weight of the liquid from curved surface to free surface. So what is happening is that water is on this side. Water is in this side. So that means it is the weight of the entire liquid that is displaced from the curved surface. So that is what is known as FV now for us. So now, yes, so this is B, so it is C, and this is A. Okay, so now it is the weight of the liquid that is displaced from ECBA. Okay, so which is, because it is displaced, it will be acting upwards. So now, so this is this, let me call it as FV2, something like that. So now I will take, because I want to find out on the cursors ACB. Now I will take ACB. Okay, ACB. If ACB, if I take, it is nothing but it is the weight of the liquid that is, okay, from the curved surface to the free surface. So only this portion for this surface, which is CA, is it not? So like this. So now since this water is acting directly on the curved surface, it will be pointing like this downwards. So which is FV1 or something like that. Okay, FV1. Okay, which is acting. So now in order to find the total, so that means here first we took weight of the liquid entire surface, that it is acting upwards. So one is, if you take this as plus, so this will be minus. So that means you are deducting this much area. So out of the total area, you are deducting this area. So what happens to the area? Only area that remains is the semicircular area. So that means in odd. So what is Fe here? It is nothing but Fe2 minus Fe1. Okay, Fe2 minus because Fe2 area is more than the Fe1 area, so it is nothing but Fe2 minus Fe1. So that means the total area ECBD is deducted like with ECA. So what remains? It is a semicircular area. So in order to find Fe for the semicircular area, that is ACB, it is nothing but the weight of the liquid that is displaced from the portion ACB. So this is how you should understand. So now directly in the textbooks they will simply deduct from semicircular area, and so why it is, you should know this. So that's why I considered first CB, and then I took weight of liquid from curved surface to the free surface, and it is displaced, so I put the force upwards. And for AC I took, because water is acting directly on the surface, so I put downwards. But that area ECA is quite less than the area, total area. So therefore what is Fe? It is nothing but Fe2 minus Fe1. Okay, so therefore what remains, the area is ACB area. So therefore it is simply semicircular area that you have to take it. So this is what is to be understood. So that's what we are going to do now. So what is Fe? It is Fe2 minus Fe1, which is specific weight into area ECBA minus area CA. But area ECBA minus area CA is nothing but area ACB. So therefore it is only area ACB you have to take and multiply with the length of the gate. You will get the weight of the water that is displaced. So that's what I'm going to do now. So this is what is to be understood. So that's why now I have drawn this sketch to explain you what is Fe. So this is, so that means I will get Fe for the portion ACB. Similarly for the oil, it is only this, because the above surface is AD surface is above the liquid, so it is not to be considered. So only the BD surface has to be considered. So therefore it is directly weight of the liquid that is displaced from the curved surface to the free surface. Okay, so therefore it is only a quadrant area that we consider for Fe. Okay, so this is what I'm going to do in the slide. So therefore now I have to consider what is area ACB. It is nothing but the semicircular area, that is pi r square, or here pi r square by 2. So r is nothing but d by 2, so it is pi d square by 8. So d is nothing but here you have that 3 meters as the diameter, so it is pi by 8 into 3 square, so which gives 3.5325 meter square. So therefore I want to find vertical pressure force, which is weight of liquid from the curved surface to the free surface. So which is, that is area into length will give volume, volume into specific will give you Fe. So this is 138.62 kilonewtons, which is acting upwards. Now next, due to oil, Fe will be, that is projected area of the curved surface, that is APV, that is 1 point. Now this is due to the water that I have determined. Now next I will take the due to oil. So here it is nothing but the projected area of the curved surface, because horizontal pressure force, only BD I have to project on to BO, it will be 1.5. 1.5 into 4 will give you 6 meters square as the area, and the CG is for the rectangular surface projected area, so it is 1.5 into 4 CG, that is 1.5 by 2 is 0.75, so therefore the CG will be 0.75 meters. Therefore the horizontal pressure force is nothing but there it is oil specific gravity. You know that oil specific gravity is 0.8, specific weight will be 0.8 into 7.848, sorry, 0.8 into 9.81, which gives 7.848. So therefore specific weight of oil is 7.848 into area, which is 6, into distance, which is 0.75. So that gives 35.32 kilonewtons. So this is nothing but the horizontal pressure force which is acting on the curved surface BD. Similarly, if you know area OBD, it is nothing but so pi d square by 4 is for the circle divide by 4 will give you pi d square by 16. So you know how to find out the quadrant. So here d is 3 meters, so therefore it is pi d square by 16, which gives area of quadrant, which is OBD. Now we know how to find out the vertical pressure force. So it is nothing but specific weight, which is 7.848, okay, into area, which is 1.766, okay, into length, which is gives the volume into specific weight. So that is 55.44 kilonewtons. Like this, so we are able to find out, and now you can combine this. Due to water and oil, horizontal pressure force which is acting to water is 176, which is in this direction, okay, like this. It will be acting like this, and for this it will be acting in this direction, like this. So therefore it is minus, so therefore we get 141.26 kilonewtons. And similarly here, you know that Fe is acting upwards, it is displaced, again Fe is acting upwards, so both are upwards, so it's be added. So due to water 138.62 kilonewtons, and due to oil it is 55.44 kilonewtons, so therefore it is 194.06 kilonewtons. Now you can find out the resultant pressure force, which is root of Fh square plus Fe square, which gives 240.03 kilonewtons. And similarly its inclination can be determined as tan inverse of Fe by Fh. So that gives 54 degrees with respect to horizontal. So this is one of the interesting problems where we are able to find out the weight of the liquid displaced from the surface. So such problems have to be dealt with. Now this is another problem which is similar to the previous problem, but only thing is it is a sector gate which is of 60 degrees. So here it is a 60-degree sector gate of radius 6 meters, and length of this sector gate is 4 meters. We have to find what is the magnitude and direction resultant pressure force exerted by the water on the sector gate. So this is the sector gate that we are interested. So this is the surface. So since it is total angle is 60 degrees, so therefore with respect to horizontal, the radius makes at angle 30 degrees. So this is what we are interested. Now I am able to find how to find out. So now you know that ABC is the surface. So in order to find FH, I have to project onto the vertical plane, that will become AC. And so using this angle, we are able to find out AC. That means you find out AD and DC and add it, and you will get AC. That you multiply by length, you will get the area. So now you take sine 30 degrees. Sine 30 is nothing but AD by AO. So therefore AD by 6 meters. So therefore I am able to find out AD. So AD is nothing but 6 sine 30, which is 3 meters. Similarly, I will get cos 30. So cos 30 is OD by OA. So similarly, so OD has to be 6 cos 30, which is 5.196 meters. So now you are able to find out OD, which is 6 cos 30, and AD is 6 sin 30. So now the projected area also I have here. So now this curved surface ABC is projected on the vertical plane AC. So AC is nothing but so AD is 3 and DC is 3. So total 6 meters. So this will be 6 meters. Okay. So this is, so now CG will be exactly at the center of this rectangular. So since AD is itself is CG distance, so therefore X bar is 3 meters. Okay, this is nothing but the projected area which I have shown here. So now this length of the gate is 4 meters. What is projected area? It is total AC, which is 6 meters, 6 into length of the gate. So that is 6 into 4, which is 24 meters square. Horizontal pressure force is specific weight into projected area into X bar, which will give 9.81 into 24 into 3. So that is 706.32 kilonewtons. So now, so you know that AD is 6 sin 30, which is 3 meters. OD is 6 cos 30, which is 5.196. So what is vertical pressure force? So it is nothing but the weight of the liquid that is displaced from portion ABCD. That's what I told you in the previous case also. So now if you take it two parts, so that means you have to, what here in the sense that it is nothing but volume ABCD into specific weight. So but volume ABCD is area ABCD into length, but what is area ABCD is area of a sector OABC minus area of the triangle. So how to find area of a sector? Area of sector is nothing but half r square theta. So area of set is theta is 30 plus 30 60 degrees. So it is half into 6 square into 60 converted to radians. So it will give you 18.84. So area of a sector is 18.84. We know how to find the area of the triangle. AC is 6 meters, whereas OD is 5.196. So therefore area of a triangle OAC is half into 6 the base into height, so that gives 15.588 meters square. So now you substitute here, so 9.81 area of a sector is 18.84 minus 15.588, which is the if you take this it will give you area ABCD. You multiply by the length, so that gives FE, that is just 127.61 kilonewtons. So therefore, I am able to find out the horizontal pressure force as well as the vertical pressure force, and this gives the resultant pressure force. So which is 717.76 kilonewtons, and also these directions can be determined by taking tan inverse of FE by FH, which gives 10.24 degrees with respect to horizontal. Same problem can be solved if we shift this water surface here exactly at the middle. So that was the what earlier case, the same problem I have taken, how the problem changes. So for me this says that this is what is given, again 60 degrees sector gate, but the water surface has changed here. So it was at A, now it is at B. So now which curved surface we are interested? We are not interested in this AB, we are interested only in this BC. Okay, so when you are trying to find out anything like the projections, it has to be for only BC, not for ABC. Okay, so this is what we are interested. So now again I require to find out, because if I try to project BC onto vertical plane, I'll get DC. So therefore I have to find out DC. So that is by sine 30 is DC by 6. So therefore we'll get 3 meters. So DC is 3 meters. If you want to find area of a triangle, then cos 30 is needed. So cos 30 is OD by OC. So again OD by 6. So therefore OD is nothing but 5.196 meters. So which is the vertical projected area? So vertical projected area BC had to be projected onto DC. So DC into length. So therefore if it is now you can mark the CG of this, and DC is nothing but 3 meters. So CG distance has to be always from the free surface, which is 1.5 meters. So this is the projected area, and similarly length. So what is projected area now? It is DC, which is 3 meters, 3 into 4. So that will give you APB. X bar is 1.5. So see the change between the previous problem and this problem. So that gives CD into length of the gate. So the 3 meters into 4, which gives 12 meters square. That will be able to find out the horizontal pressure force, which gives 9.81 into 12 into 1.5, which gives 176.58 kilonewtons. Now again we are required to find out the FV here. So for that we need CD and OD, which is already determined. So what is vertical pressure force? It is nothing but the weight of the liquid displaced from the curved surface to the free surface. So which portion you have to take? So only this portion. Last time, so the curved surface is here. So yes, this free surface is here. So that means it is only this portion. So this is what. So last time we took entire thing, so now we are taking only this. So it is the how to find out this area? It is area of a sector OBC minus area of a triangle ODC. So it is weight of liquid displaced from portion BDC. So it is nothing but volume BDC, which gives area BDC into length, which is volume, into specific weight. So it is area of sector OBC minus area of triangle ODC into length of the gate. into specific weight. So how to find area of sector OBC is you have to take 30 degrees. So therefore half r square theta, half 6 square into theta is last time you took 60 degrees, now it is 30 degrees. 30 into pi by 180, which gives 9.42 meters square. Similarly, area of triangle ODC is half base, that is this DC is 3 meters and OD is 5.196. That gives 7.794 meters square. So find out FA by substituting here. So length of the gate is 4 meters. So that gives 63.804 units. So similarly, we have horizontal pressure force, which you already determined. We have found out vertical pressure force. So that gives the resultant pressure force, which will come to 187.75 kilonewtons. And its angle is tan inverse of FA by FH, which is 19.87 degrees. So see the change in the problems that you compare. So as the free surface